In this video, I would like to discuss the topic of unusual values. Values in a set that are considered statistically unusual. So I have an example here of two animals, and I've given you some information about the mean and the standard deviation of the height of a male giraffe. Okay, so we have the mean height of male giraffes is 16.3 feet, and the standard deviation is 3.3 feet. Right? And then we have some information about a great white shark. The average length of a female great white shark is 15.6 feet. So let's write that down, 15.6 feet for the mean length with a standard deviation of 3.9 feet. So now the question is, over here, I'll put a little blue box around the question. The question is, what would be considered more statistically unusual? A 24-foot tall giraffe or a 24-foot long great white shark? Okay, so if a giraffe is 24 feet tall, that would be 7.7 feet above average. And if a great white shark is 24 feet long, that would be 8.4 feet above average. So we've got 7.7 feet above average for the giraffe, 8.4 feet above average for the shark. So you might say, well, the shark is more above average than the giraffe, so the shark would be more unusual. Well, it doesn't work that way. These are animals coming from two different sets with two different means and two different standard deviations. So in order to compare the two and determine which is more statistically unusual, we have to standardize that difference from the mean. And what that means is convert to z-scores. So first, let's just review our definition, our statistical definition of unusual. So let's say this is a number line. Let's put 0 in the middle and 1, 2, 3 on the positive side, -1, -2, -3 on the negative side. Okay, so let's consider these are number of standard deviations away from the mean. Well, our definition of statistically unusual events is any value within 2 standard deviations of the mean. So plus or minus 2 standard deviations. We call those ordinary values. Now, some books say 3, some books say 1, but most statistics textbooks will say 2. Our book that we're using for this class says 2. And anything more than 2 standard deviations above the mean, we call those values unusual or unusually high. And any value more than 2 standard deviations below the mean, we call those unusually low. And so we don't, it's a little cumbersome to keep saying the number of standard deviations above the mean and the number of standard deviations below the mean. So we sort of abbreviate that by calling it z-scores. Right? The z-score is this unit of measurement, and it's not measured in feet or miles or pounds or ounces. It's measured in number of standard deviations. It is the standard statistical unit. And it allows us to compare values from different sets. So what we want to do is convert the x values or the data values into z-scores. And to do that, we have a formula. Z is equal to x minus the mean divided by the standard deviation. All right, so this will allow us to convert x values to z-scores. So for the giraffe, the x value in question is 24 feet. X is 24. We know the mean is 16.3 that was given, and the standard deviation is 3.3 that was given. So the z-score for a 24-foot tall giraffe. So converting 24 feet tall into a z-score would be x, which is 24, minus the mean, which is 16.3, divided by the standard deviation. So that will give us 7.7 on top, 3.3 on the bottom, and if you pop that into a calculator, you will get approximately 2.33. Approximately 2.33. 2.3 repeating. Let's round to 2. Generally, we round z-scores to 2 decimal places. Okay, and we'll do the same thing for the shark. Convert the 24 feet long to a z-score. And for that, we need the mean, which is 15.6. We need the standard deviation, which is 3.9. So the z-score for the 24-foot long shark would be x minus the mean divided by the standard deviation, which is 3.9. So on top, 24 minus 15.6 will give us 8.4. Divide by 3.9, and you could pop that into a calculator, and you will get about 2.15. Okay, so what that tells us is these are both unusual events, unusual observations. A giraffe measuring 24 feet tall is unusual. A great white shark measuring 24 feet long is unusual, but in this case, the giraffe is more unusual because it has a larger z-score. It is further from average, not measured in feet, but measured in number of standard deviations. So the higher, or the farther away from the mean the z-score is, or the farther away from 0 the z-score is, the more unusual. All right, that is it for this video. I hope this has helped to explain this connection between z-scores and unusual values.